Okay, so what this proof says ne, is this. If now I have two Cartesian, or let's say I draw a Venn diagram like this. Let me just draw a Venn diagram. And then I have A, set B. You see, right? And we know that all this is, let me just write this. And so we know that all this is A union B. You see, right? But we can do this. We can divide this into two. We can say here that this is A. You see this, right? This is A. And this, you see, this is B and A complement. And this whole thing is A. And then we know that in the middle here, we have A and B. This is intersection. And this one, let me draw it like this. And this one. This one. You see, right? It's A and B complement. So what they did here, right? They decided to take the union of A and B. They took it like this. They took it as A. This is A union B and A complement, which is this. And these two are mutually exclusive because once we divide them like this, they don't intersect. They don't have any intersection. You see, right? So we say that now from here, I can just multiply this through A union B, which is this, A union A complement, which is this, and this one gives us universe S. Yeah, let me just say gives us S, and then it comes back to having A union B. Then what you have here is that A union B and A complement is equal to A union B. We see, right? So what you can do from now here is come and introduce a probability. When it comes to introduce P here, this will change to plus when you distribute. You see, right? Or you can say that this will be probability of A. You just put P here, P. Then when you start to apply this probability, you're gonna say that this is the probability of A plus the probability of B and A complement. You see, right now. Then from here, you say that this is also probability of A union B. Then you make you see what they did? They just wrote this to be like this. You make it with the formula. You see, right now, in this way. Then what you need here is probability of B minus probability of A and B. We see. And you know that the probability of A and B can be written as the probability. This can be written as the probability of A minus the probability of A and B. We agree there, right now? So that can be written as, how do we know that? This whole set, let me come back here. When you have this whole set as B and you're looking for this part only, you're going to say the probability of this B minus the probability of the intersection for you to get this whole part. You see, right? That's how you get that this proof is correct. Which this can also be proved in another way. Which in another way, we can also come here and say this. We can say, let's say we have this. Let's say we have this the same two Cartesian. Let me just say that this is the same two Venn diagrams. Then we know initially that this is the probability of A and the B complement. This is the probability of B and the A complement. And this is the probability of A and B. I'm sure we agree here. And we know that we're looking for the probability of A and B. Right? Since we're looking for the probability, no, we know that we're looking for the probability of A union B. So since we're looking for that probability of A union B, we can come and say that we know that for us to have A union B here, let me just start by writing like this. For us to have A union B, we must have A and B complement union. I'm taking these individual, you see, right? Then let me put union A and B union B and A complement. Then if I come to put the probability here, I'm going to have the probability of A and B complement plus the probability of A and B plus the probability of B and A complement. Then I know that I can find these individually. So let's go find them. If I'm looking for the probability of A and B, right, I can just find the probability of A. Right, we know that the probability of A will be given as the probability of A and B complement plus the probability of A and B. So what I need here is the probability of A and B. So I can just make the probability of A and B subject to the formula. Probability of A and B complement, that's what I need. So I can just make that subject to the formula. And then I'll have probability of A minus probability of A and B. Like that, if I take this to the other side. And then, now I come look for, I want this one again, which is this. Now I come just do the probability of B. We know that the probability of B will be equal to the probability of A. This is just A complement. Let me just put it like this. Write it as it is. Complement plus the probability of A and B. So I can just make that one subject to the formula. Probability of B and A complement, which is equal to the probability of B minus the probability of A and B. So I know I have this and this. Let me just call this one, I'll just call this one, well, let me just call this one star. I'll call them like this. I'll call that one star and then the other one 2 star and 3 star. And call this one star. Call this one 2 star. So this one, call this one 2 star. And then call this one 3 star. Then what I can do now is sub 2 star and 3 star and star. So it means that this will be, is this star? Yeah, star is for this one, right? Yeah, I made a mistake here. Star is for the first one here. I'm trying to put them to be like this. Yeah, this is star. So I'm going to substitute those on that one, right? Where I'm going to have the probability of A union B. And now the probability of this one, right? It's this. So I'm going to have this as the probability of A minus the probability of A and B. And there I have plus probability of A and B, which is this one. Then this one, I come and substitute this, which is plus the probability of B minus the probability of A and B. So what I've realized is that this and this are going to cancel out. So we are going to be left with probability of A plus this one, probability of B minus the probability of A and B, like that.